Now that we know electronics is concerned with using components to manipulate tiny amounts of electricity, we should probably answer one more question before we proceed. What exactly is electricity? Electricity is a form of energy that results from the presence of charged particles. In particular, we focus our discussion on the particle called the electron, from which both electricity and electronics get their names. In a simplified model of an atom, electrons are thought of as tiny particles orbiting around a much larger nucleus made of protons and neutrons. Electrons are said to have a negative charge, which is equal to and opposite of the positive charge held by protons. Neutrons have the same larger mass as protons, but carry no charge. Here's a diagram of a lithium atom with 3 protons and 4 neutrons in the nucleus, and 3 electrons orbiting around the nucleus. Because there are an equal number of positive protons and negative electrons, the atom has no overall electrical charge. Because of the way electrons configure themselves in their orbits around the nucleus, it's possible in most elements for an atom to lose an electron, leaving it with 1 more positive proton in the nucleus than the negative electrons in orbit. The atom now has an overall positive charge and is called a positive ion. It's also possible for an atom to gain an extra electron, perhaps from a neighboring atom who has lost one, and become a negative ion. The negative electrons outnumber the positive protons, giving the atom an overall negative charge. Here's a copper atom, a metal that's really good at conducting electrical energy. That simply means something like a copper wire easily allows electrical current to flow through it. The copper atom has 29 protons and 34 neutrons in its nucleus, and 29 electrons in orbit. Because of the way the electrons arrange themselves, there is a single, lonely electron orbiting a bit farther out than the other 28. It's this electron that can be easily lost to a neighboring copper atom, and it's the same electron orbit that can gain a second electron easily. Now imagine a length of copper wire. It's full of trillions of copper atoms, all quite close to one another. It's easy to imagine how a single electron could be lost from one atom, picked up by a second, be lost to a third, etc. In fact, in a typical length of copper wire, there are billions of freely roaming, randomly directed free electrons, moving back and forth from one atom to the next. Now, the curious thing about electrically charged particles is that they do one of 2 things when they meet another charged particle. In the absence of any other forces, they are either attracted to one another or repelled apart. The rule for this is very simple. Unlike charges attract, like charges repel. So 2 electrons will normally move far away from each other, and an electron and a proton will normally try to get as close together as possible. The reason they don't inside of individual atoms is because there are other forces at work which hold the atom together and keep the electrons orbiting the nucleus. But those free electrons in the copper wire do not have to follow these same rules. If we place a positive charge at one end of a copper wire and a negative charge at the other, we can direct the flow of free electrons and create an electrical current. The free electrons are attracted to the positive charge at one end and repelled by the negative charge at the other end of the wire. As long as we supply those 2 different charges, electrons will flow in the wire in the form of an electric current. In a typical electrical application, a battery of some sort will supply these 2 different electrical charges. On one end of the battery is a positive terminal that supplies a positive charge, and on the other a negative terminal that supplies a negative charge. We should never directly connect these 2 terminals with only a conductor, because there will be nothing to limit the amount of current flowing in the resulting electrical circuit. Every circuit must have what is called a load, a component or components that use up some of the flowing current and prevent it from flowing too fast. Here's a simple circuit with a battery and an electric lamp. In this example, the battery supplies the positive and negative charges, and the lamp provides the load that uses up some of the flowing current, limiting its rate. By the way, if you were to accidentally connect the positive and negative terminals of a battery with only a wire, you would create what is called a short circuit. With nothing to resist or limit the flow of current in the wire, either the battery or the wire or both would be quickly destroyed. A short circuit is always a dangerous situation, and is always to be avoided. We'll learn more about loads and short circuits when we begin creating actual circuits in a later section.